This is an A-level further statistics 1 question on applying the central limit theorem to a discrete distribution. A bias spinner can land on the numbers 1, 2, 3, 4 and 5 with the following probabilities, and here they are on this table, this probability distribution. The spinner will be spun 80 times and the mean of the numbers it lands on will be calculated. Find an estimate of the probability that this mean will be greater than 3.25. Now this question will require use of the central limit theorem, which says that the sample mean will be normally distributed where we have the mean of the population, that's the mean of the sample means, and its variance is going to be the variance of the population over the sample size n. Now I'm going to start by setting up my random variable x, and I'm going to say that x is going to equal the number of times. So the random variable is always the number of something. So it's the number of times the spinner is spun. Now this is optional, writing this down, but it does really help you to get your head around the question. So the spinner is spun. Okay, now for this question the mean of the population is going to be E of x, so that's calculating the mean from this table, and E of x is going to be 1 times by 0.3 plus 2 times by 0.1 plus 3 times by 0.2 plus 4 times by 0.1 plus 5 times by 0.3. So that's going to be 0.3 plus 0.2 plus 0.6 plus 0.4 plus 1.5. That's 5 times 0.3. And if we add those up, let's do that. So we've got 1.5, adding those together, make 2.5, 3. So we get exactly 3 for E of x. Now we want the variance of this probability distribution. That's going to be var x. Now remember, var x is E of x squared minus the mean squared. Now we've worked out the mean, so we're going to be subtracting 3 squared. So E of x squared, that's going to be 1 squared times by 0.3 plus 2 squared times by 0.1 plus 3 squared times by 0.2 plus 4 squared times by 0.1 plus 5 squared times by 0.3, and that comes in at 58 over 5, which is equal to 11.6. And then what I need to do, actually this whole calculation here is E of x squared, so strictly speaking I should put on the end here, put this in brackets, and put minus 3 squared. So that gives 58 over 5 minus 3 squared, and that's 13 over 5. Okay, so I've got my population mean 3 and I've got my population variance 13 over 5. So the sample mean is going to be normally distributed, so I guess I should write by the central limit theorem. So rather than just write it out, I should state that I'm now using the central limit theorem. The sample mean is normally distributed with a mean which is going to be E of x3 and a variance of 13 over 5 divided by n. Now the spinner was spun 80 times, so my sample size is 80. Now we want to find an estimate of the probability that this mean, this sample mean, will be greater than 3.25. So we want to find the probability that x is greater than 3.25 or greater than or equal to, it doesn't matter, it's a continuous distribution. If you want to sort of draw that out so you can physically see what it looks like. So here's my sample mean. The mean of this is going to be 3, and the standard deviation of this is going to be the square root of this 13 over 5 divided by 80. Now if I do 13 over 5 and I divide it by 80, you get 13 over 400. So it's root 13 over 400, like that. And then I'm just going to use my calculator to calculate this probability. Now greater than 3.25, so if this is my 3.25 here, this is the area that I'm trying to calculate. So I know this, it has to be less than 50%. So this gives me an idea of the size of my answer. So if I got an answer bigger than 50%, I would need to go back and check that my working is correct. So we use normal CD, we've got a lower value of 3.25, we want an upper value at least 5 standard deviations away from the mean. I just normally just type in any big number, so I've just typed in 9999, that's definitely going to do the job. For my standard deviation, it's going to be the square root of 13 over 400. And then my mean is going to be 3. Okay, doing that all on the calculator, what I get for the probability that the sample mean is greater than 3.25, 0.0827, 5, alright, I wrote down 7 when I said 5, 8, 9, and so on. Now an answer to 3 significant figures is adequate, so 0.0828, so that will be to 3 significant figures.